Hello everyone, welcome to my YouTube channel Chemistry Lover. So today in this video I have shown you another rearrangement which is known as Claisen rearrangement. Now first of all, this is a rearrangement and it is basically an example of sigmatropic reaction, and sigmatropic reaction is basically a part of pericyclic chemistry, right? So here you can see it is a vinyl allyl ether because the oxygen is directly connected to the vinylic carbon atom. On the other hand, it is connected with the allylic center of, here you can see this is allylic and this is vinylic, so we can name this compound allyl vinyl ether. Now it can undergo Claisen rearrangement under photochemical condition, or you can also heat this molecule to some extent, where this pi bond shift between 2 to 3, and this bond between carbon and oxygen also break, and the pi bond between second and third position also shift, and in this way here this is formed. This is gamma delta carbonyl compound. This is our mother molecule, that is reactant, which is allyl vinyl ether, and it is the gamma delta carbonyl compound. Now how this reaction take place, let's see. First there is a transition stage take place. I have seen here, this is the transition stage where the single bond between carbon and oxygen will break, and hence I have numbering these two atoms A1 and A2. A1 and A2 means atom 1 and atom 2. Atom 1 means the oxygen and atom 2 means the carbon. Since the single bond between carbon and oxygen is going to be break, hence I have numbered these two atoms as A1 and A2. Similarly, the single bond again form take between A4 and A3, because this pi bond shifted to third carbon to another third position of the carbon atom. Hence there will also a single bond formation take place between A4 and A3. Hence I have numbering these two atoms between which the bond will be break and formation take place, and in this way the transition stage is formed, where the black line indicates the bond formation and green line indicates the cleavage of bond, that is breaking. And from this transition stage we can get this compound, which is gamma delta carbonyl compound. Gamma delta means this is alpha, you should know this position alpha, this is beta, this is gamma, and this is delta. So with respect to carbonyl functional group, the pi bond present between gamma delta position, hence we can name this compound as gamma delta category. Now here I have written some important information which you should know regarding this topic. Now first, this rearrangement takes place on the allyl vinyl ether, which I have told you already, because this is mainly allyl vinyl ether. And second point, it is basically an example of 3,3 sigmatropic reaction. This is a 3,3 sigmatropic reaction, which is an example of pericyclic chemistry. Now another important thing, that is mark those two atoms between which the bond will be break and formation take place. Since the bond will be break, here I have seen you the single bond break between oxygen and carbon atom, and another the single bond formation take place between two carbon atoms, and this formation and breaking take place gradually at the same time and the same extent. Hence I have numbered these two atoms between which the bond is going to be break and formation take place here. Hence I have marked these two atoms between which the bond will be break and formation take place. Now another example I have considered here, you can see this molecule, it is also allyl vinyl ether, where in case of vinyl I have considered phenyl. Since phenyl is also a vinylic system, 6 carbon atoms are sp2 hybridized, aromatic nature, etc. So this is phenyl ring directly connected to the oxygen atom, and this oxygen again connected with the allylic position of another system, another alkyl group. So in presence of heat, it also undergo Claisen rearrangement and obtain this type of product. So here such type of intermediate form, and it is very unstable and very unstable because it loses its aromaticity, hence it cannot stay into the reaction medium for many periods of time. So this type of intermediate is very unstable, hence we cannot isolate this type of intermediate from this reaction mixture, hence the product readily formed from the reactant as well as the mother molecule. Again, I have numbered this oxygen and carbon atom of phenyl ring as A1 and A2 because the single bond between oxygen and carbon will be break, and as well as the orthocarbon and the allylic carbon atoms, they form the single bond between them. Hence I have drawn the transition stage in this fashion. So up to this, if you have any doubt regarding this theory, then please ask me through the comment section, and if you like this video, then don't forget to hit the bell icon. Thank you.